Today's lesson is on geometric sequences. So we're going to look at a list of numbers and determine if they're geometric, if it's a geometric sequence, and we're also going to use it to write some formulas. So a geometric sequence is the ratio of consecutive terms, or is when the ratio of consecutive terms is constant. In other words, in our list of numbers, we are going to multiply by something to get to the next number. So what we multiply by is called the common ratio. It is going to be the letter R in our formulas. So it's not like an arithmetic sequence where we add or subtract to get to the next term. Geometric is multiplication. So always be looking for that. Don't be looking for the add or subtract. All right, so example 1 says that makers of Japanese swords in the 1400s repeatedly folded the hammered the metal to form layers. The folding process is increased with the strength of the sword. The table shows how the number of layers depends on the number of folds. Write a recursive rule and an explicit rule for the geometric sequence represented by the table. So the number of folds is at the top and the number of layers is at the bottom. So we have to find the common ratio. So we do that by taking the second term and dividing it by the first term. So 4 divided by 2 would be 2. And then the next term divided by the term in front of it. So 8 divided by 4 is also 2. Then 16 divided by 8 and 32 divided by 16. So the common ratio is 2. So R equals 2. All right, so now we're going to start the process of writing the recursive rule. So f of 1, that just stands for the first term. So the first term in our list is 2. It's starting right here. So that's a 2. All terms after the first term are the product of the previous term and the common ratio. So product is answer to the multiplication. So you're going to take that first term and multiply it by 2. That will give you the second term. Then you're going to take the second term and you're going to multiply it by 2. That's going to give you the third term. You're going to take that third term, multiply it by 2. It's going to give you the fourth term, and so on. The recursive rule is stated by providing the first term, which we have already decided is 2. So you always have to have f of 1 equals that first term. You can't write a recursive rule without knowing the first term. And then the rule for the successive terms. So the number of the term, we have to take the term before it and subtract 1. So if we want the fifth term, we are going to do 5 minus 1. Sorry, 5 minus 1, I write 4. 5 minus 1, and we get 4. So to find the fourth, we take the fourth term and we multiply it by 2 to find the fifth term. So one more time. If I want the 10th term, I'm going to put 10 minus 1, which is 9. So that means I'm going to take the 9th term and multiply it by 2 to find the 10th term. Okay, so no matter what term you want to find, you have to take the one before it and multiply it by 2. The other part you're always going to have is this right here. The n is greater than or equal to 2. That is because you have to have the first term in order to do this rule. If you don't know what the first term is, then you can't find the second term. So that means you have to have that first term. So you're going to start by finding the second term. So that number of the term, which is labeled n, has to be greater than 2 or equal to 2. So you have to start at the second term. So that always has to be in that recursive rule as well. Now, the explicit rule is a little bit easier. It's always in the same form here. So you need to have that written down somewhere. A is your first term. R is the common ratio, what you're multiplying by. And n is the number of the term that you're trying to find. So if I want the recursive rule for the up above, I have a times r to the n minus 1 power. So the first term was 2. We also found out that the ratio, the common ratio, was 2. And then we have n minus 1 up here. So if I wanted the 10th term, I would do 2 times 2 to the 10 minus 1, which would be 2 times 2 to the 9th power. So then I would have to do 2 to the 9th power first, because we have to do exponents first, and then take that answer and times it by 2 to find the 10th term. Okay, so now we have to look at this, what is given in the explicit rule. And remember, this is a times r to the n minus 1. So f of 1 stands for the first term. A stands for the first term. So in this case, 5 is our first term. In these parentheses is always going to be n minus 1. And then we're going to multiply by our common ratio. Our common ratio is given by r. So in this case, it would be a 4. So an n is greater than or equal to 2. You have to add that part on. So this is our, well, all of it really is our recursive rule, because you have to give the first term, then you have to give the rule. So you take, this means the previous term, right here, previous term times 4 is our rule to find the next term. All right, example 2. The shutter speed settings on a camera form a geometric sequence where a of n is the shutter speed in seconds and n is the setting number. The 5th setting on the camera is 1/60th of a second, and the 7th setting is 1/15th of a second. Write an explicit rule for the sequence using subscript notation. So step 1, identify the given terms in the sequence. So the 5th term, the 5th setting is 1/60th, and the 7th term is 1/15th. Now this part, finding the common ratio, is going to get a little bit tricky here on us. So the 7th term, so a to the a sub 7 here, this right here, means the 7th term is equal to the 6th term times the common ratio. And the 6th term is equal to the 5th term times the common ratio. So we have to rewrite this. We kind of have to use substitution. So a to the a6, the 6th term is right here. This is what the 6th term equals, this right here. So we're going to substitute that in, because the 6th term equals the 5th term times r. So we're going to replace the 6th term right here with the 5th term times r, and then we have the rest here times r. So once we have that, then we can go back and fill in the two numbers that we know. We know the 5th term is 1/60th, not 16th. And we know the 7th term is 1/15th. And we also know that r times r is r squared. Okay. So now we have to turn this into an upside down t problem and solve. So 1/60th times r squared, I can divide by 1/60th and figure out what r squared is. And 1/15th divided by 1/60th is actually 4. And then to cancel out a squared, we're going to do the square root. So that's going to leave us with r. And the square root of 4 is 2. So we just figured out that the common ratio is 2. Then we're going to use that to find the first term in the sequence. So we're going to plug in one of the terms that we were given. So we just figured out that r was 2, and we also know the 5th and the 7th term. So I'm going to pick the 5th term. to plug in here. So the fifth term would be our answer, which would be 1/60th, and I keep writing 16. The first term is what we're trying to find. We don't know what A1 is. R is 2, we just figured that out. And we know that this is a fifth term, so 5 minus 1 here. So now 1/60th equals A times 2 to the fourth power. 5 minus 1 is 4. 2 to the fourth power is 2 times 2 times 2 times 2. So that would be 2 times 2 is 4, times 2 is 8, times 2 is 16. So 1/60th equals A times 16. Then I'm going to divide by 16. And I'm going to get A equals 1 over 960. So our first term, that A sub 1, is 1 over 960. Step 4, we're going to write the explicit rule. So now we're going to plug in all of the stuff that we know. So A sub n is going to be whatever the answer is, whatever term we're asking to find. A sub 1 is our first term, which we just figured out was 9/60ths. We figured out R was 2, and then we have n minus 1. So if I wanted the 15th term, I'm going to put 15 in there for n.